Hello, good day. I am Gecris Marquez from Protection National Trade School, Master Teacher 1, Teaching Science. Um, Before anything else, I would like to um, greet my co-participants here in the training platform, including the respectful resource speakers, and as well as the management team of the Magister Service. My research is entitled Development and Validation of Project IOSBA, or what we call as Interactive Offline Smartphone-Based Android Application in Teaching Science. The context and rationale for my research. The context and rationale for the action research are based on the alarming performance of the Philippines in the international assessment of student achievement, particularly mathematics and science. The study focuses on the low achievement rate in science and aims to address the issue by exploring the potential of an interactive offline smartphone-based application to enhance science education. The 2018 PISA results revealed the country's poor ranking in mathematics and science, and the 2019 TIMSS results showed the Philippines receiving the lowest rating among 58 nations. Science education is identified as challenging for both teachers and students, requiring a shift from traditional methods to more engaging approaches. The 21st century learners described as technology savvy show the interest in educational applications on mobile devices. The proposed solution involves leveraging the popularity and familiarity of smartphones to create an interactive offline application for science education. This approach aims to bridge the gap between the theoretical knowledge and real world applications, providing students with a more immersive learning experience. The study aligns with the shift toward inquiry based teaching approaches and recognizes the importance of integrating technology to support formative assessments practices. The science curriculum in the Philippines emphasizes the development of competencies essential for knowledge-based society. However, the challenges faced by high school science teachers, such as low attention uh, from students and low achievement rates, prompt a re-evaluation of teaching strategies. The Division Achievement Test, or DAT, results further highlight the need for improvement, particularly in science subjects. The researcher proposes Project IOSBA as potential solution to address these challenges. The choice of the ADI model for instructional design ensures a systematic approach to the development of the interactive offline application. The model involves analysis, design, development, implementation, and evaluation, providing a structured framework for creating effective learning experiences tailored to the needs of students. The rationale of using smartphones is justified by their popularity, accessibility, and potential to enhance learning. The study acknowledges challenges such as slow internet connections and emphasizes the need for technology integration in education to accommodate different learning paces. The goal is to provide an innovative and creative learning experience that captures students' interests and improves their understanding of science concepts. Now, for the action research question, the primary objective of this research was to develop and verify an instructional resource named Project IOSBA, the interactive offline smartphone-based Android application. This learning tool was aimed at aiding grade 9 students at Tawagan Sur National High School located in Tawagan Sur, Pagadian City, Zamboanga del Sur in enhancing their performance in learning science concepts and skills specifically in the topic of respiratory and circulatory system, grade 9 science. Specifically, the study sought to answer the following queries. Number one, what is the extent of the educational soundness of the Project IOSBA based on 1.1 integrity, 1.2 learner focus, 1.3 usability, and 1.4 accessibility. Number two, what is the extent of the quality of the Project IOSBA content in terms of 2.1 content quality, 2.2 instructional quality, and 2.3 technical quality. Number three, what is the extent of validity of Project IOSBA in terms of 3.1 design, 3.2 accessibility, 3.3 accuracy, 3.4 usability, 3.5 reliability, 3.6 functionality, and 3.7 efficiency. Number four, what are the comments or suggestions or recommendations made by the expert validators on the developed Project IOSBA? Based on the findings, what enhancements can be made to make Project IOSBA more useful to learners? Now, the proposed innovation, intervention, and strategy. With the guidance of the Science Education Framework in the Philippines, the researcher developed a mobile application known as the IOSBA, or Interactive Offline Smartphone-Based Android Application. This application was designed with the intent of reinforcing the science capabilities of junior high school students, aiming to elevate their performance in this subject. The application's design aimed to immerse students in an experiential and situated learning approach, aligning with the principles of the conceptual framework. Through this application, students were given the opportunity to improve their learning of science concepts and skills by providing supplementary resources to enrich the teaching learning process. Since the application is offline, this allowed students to immerse themselves both at a cognitive level and a practical level while using the application even without internet connectivity. Project iOS is an Android-based mobile application. Developing the interactive offline smartphone-based Android application involves several steps, including design, content creation, and technical implementation. A systematic procedure guides the process. First, it starts with conceptualization and design, where MS PowerPoint is used to create the foundational elements like the homepage and main pages. Wireframing and prototyping follow, refining the design with tools like Adobe XD to visualize the user experience. Interactive content creation using tools like the Lumi app adds multimedia and engaging elements. Simultaneously, HTML content is coded with Notepad for text-based information, converting to an Android app with Website 2 APK Builder is a significant step, followed by testing and optimization to address issues. Offline functionality implementation ensures a seamless user experience even without internet connectivity. Following these steps results in an interactive offline smartphone-based Android application that provides engaging content, a well-designed interface, and offline capabilities for learners. Now, Project Aisbaa will be distributed to the students via Android package or APK through Bluetooth or wireless local area network or WLAN. Upon running the application, it allows students to browse in the different parts of the learning module. Students will be presented with the lesson introduction, discussion with graphic illustrations, activity instructions, assessments, and supplementary tasks, such as identifying the part of the respiratory system and arranging images. The researcher purposely selected the mobile-based application since they can significantly improve students' academic achievement and performance. These are the components of the ISBA. We have the home page, we have the main page 1, the main page 2, the author page, the last is the author page. Aligned with the framework proposed by John Leib and Etienne Wenger, a study conducted by Gawandi and Al Sunaidi in 2015 titled Situated Learning, Learning in a Contextual Environment suggests that students learn not only through active participation in classroom activities and teacher-led lectures, but also via self-paced learning endeavors. The action research methods, the research design, The research design employed in this action research follows a descriptive developmental approach, focusing on crafting an instructional resource named Project IOSBAA. The primary goal is to enhance the science capabilities of junior high school students, ensuring educational quality, accessibility, and relevance while improving their understanding and application of concepts and skills. Descriptive research is used to portray the current state and details of the situation, providing a comprehensive snapshot and understanding of the phenomena under scrutiny. This method is considered efficient, practical, and flexible, allowing for both qualitative and quantitative data collection. The participants in the study include expert validators who assess both the content and the ICT performance of Project ISBAA, the four master teach the three master teachers in science and one supervisor in learning resource management and development system or LRMDS validated the content, while the three ICT practitioners evaluated the ICT performance of the application. The data collection process incorporates qualitative and quantitative elements, utilizing interviews to gather perspectives and emotions. Evaluation tools such as the LRMDS Educational Soundness Evaluation Checklist, the evaluation rating sheet for non-print materials, and a functionality survey adapted from the IEEE criteria were employed to assess the content and performance of the project ISBA. Data analysis involves both descriptive and inferential statistical methods. The statistical measures such as the mean, the percentage, and the standard deviation are utilized to gauge status and variability of the experiment and control groups. The Microsoft Excel is employed for data organization and statistical calculations with a hypothetical mean range, classifying for interpretation. The interpretation range includes very low, low, high, and very high categories based on the mean values. The process aims to provide a comprehensive analysis of the effectiveness and quality of Project IOSBAA in enhancing students' learning experience in science. Now, for the results and discussion, this part reports the analysis and interpretations of the data gathered during the development and validation of the interactive offline smartphone-based Android application or ISBAA. The summarized data obtained from the investigation is presented through tables, followed by the analysis and interpretation of the data through textual discussion based on the sequence shown from the statement of the problem. Discussions also include the presentation of literature report, support, and arguments to prove what is being claimed in this research endeavor. First, point is the validation of the educational soundness of interactive offline smartphone-based Android application. Before subjecting the interactive offline smartphone-based Android application to content validation, it underwent a comprehensive LRMDS educational soundness general evaluation. One primary criterion that any learning material needs to achieve before it can be allowed by the LRMDS of the Department of Education to be used by the learners is the educational soundness of the learning material. The primary objective of this evaluation was to assess the suitability of the learning material for reproduction, redevelopment, or inclusion within the LRMDS catalog of quality assured learning resources. The validators rating distinctly indicate the educational soundness and validity of the ISBAA's content. The evaluation outcomes, particularly concerning integrity, learner focus, usability, and accessibility, are illustrated in Table 2. According to the findings, the overall educational soundness of the application achieved a perfect score of 100% across critical categories including integrity, learner focus, usability, and accessibility. The unanimous agreement among all validators in providing a yes rating for each quality in educational soundness tool for LRMDS underscores the high level of approval and consensus regarding the application's positive attributes in these crucial areas. In summary, the IOSBAA demonstrated strong educational soundness with favorable evaluations across various dimensions by the validators. Next point is the validation of the contents of the IOSBAA, another primary criterion for the validation process essential for the approval of this interactive learning mobile application to be used by the learners is the educational quality review and evaluation. This validation process determines the material's appropriateness for educational use and ensures their accuracy and freedom from errors. The validation criteria encompass multiple facets, including content quality, instructional quality, technical quality, accuracy, and currency of information. Table 3 presents the validation outcomes provided by expert validators for the interactive offline smartphone-based application contents. Now, here are the results. For content quality, the mean is 4.0 and the standard deviation is 0.00. Interpretation is very high. Same with the instructional quality, which garnered 4.00, mean of 4.00 and a standard deviation of 0.00 with the interpretation of very high. Technical quality is 3.96, the standard deviation is 0.06, and the interpretation is very high. Other findings, other findings included in the content validation garnered 4.00 mean and a standard deviation of 0.00. Interpretation very high, with an overall mean of 3.99 with a standard deviation of 0.02. Interpretation very high. The results of this validation effort revealed that the contents of the ISBAA achieved a remarkable high rating denoted as very high. Notably, the results for the standard deviation suggest a strong consensus among validators regarding the very high instructional quality of the mobile application. Of particular significance is the content quality of the ISBAA, which obtained one of the highest scores, similar to the other indicators, with an exceptional assessment of very high. The results suggest that the mobile applications aligns well with the DepEd learning competencies, demonstrating accuracy, relevance to real-life situations, and cultural sensitivity. It enriches and reinforces learning objectives, fosters critical thinking, and promotes positive values. Lastly, the result in the other findings confirms the following. The ISBAA is conceptually and factually error-free. It also possesses no grammatical errors or computational typographical information or visual errors. The result confirms a highly usable interactive mobile application that DepEd students can use. Deloach, Miller, and Rosengren in 1997 emphasized the importance of learning materials without errors. It was suggested that conceptual and factual errors can significantly impact children's ability to comprehend and use new information. They have found that when errors are present, learners may experience decreased self-confidence, which can be detrimental to the child's overall development. To develop mobile application in teaching science, 9 shows to obtain at the standard level as error-free material. This implies that the interactive offline smartphone-based Android application is quality learning material suitable for use amongst DepEd students. Last point is the validation of the performance of the IOSBAA. The table 4 shows the results of expert validators, validation of the offline smartphone-based application in teaching science, anchoring its performance against the corresponding criteria. The overall performance of the IOSBAA was exceptionally high, with the overall mean of 3.95, standard deviation of 0.08. Considering the range of deviations, it is apparent that the responses from expert validators regarding the application's performance criteria are very consistent, indicating a high degree of similarity. Now for the comments and suggestions by the expert validators. The qualitative findings are also one of the major bases of the validation process, shown in table below, is the summarized presentation of the different comments and suggestions of the members of the validation team. This summary is subdivided into different components of the interactive offline smartphone-based Android application. This includes the following: the homepage, the main page 1, which contains the interactive module, the main page 2, which contains the interactive activity page, and the author page. So here are the comments and suggestions from expert validators. The researcher thoroughly analyzed and considered major comments on the interactive offline smartphone based Android application, addressing the initial feedback. Positive remarks were noted for the homepage, aesthetics prompting a suggestion to incorporate a brief tutorial for the first-time users. Additionally, commendation was given to the visual appeal of the main page, particularly the interactive module, coupled with a recommendation to perform compatibility tests across different devices for a seamless user experience. The user-friendly design of the interactive activity page was acknowledged, accompanied by a suggestion to test its functionality on various devices. Lastly, a cautionary note was emphasized for the author page, urging the researchers to check for potential accessibility issues to enhance inclusivity. For the final and improved iOS BAA in teaching science, based on the experts' comments and suggestions for improvement during the validation process, the following revisions are made to make the interactive offline smartphone-based Android application more engaging, useful, and helpful to both learners and teachers. First, despite positive feedback on homepage aesthetics, the inability to add a quick tutorial for the first time users due to the complexity of the application creation process could be reconsidered, simplifying the tutorial creation process. If possible, would enhance user onboarding. Additionally, while functionality tests on various devices have been conducted, ongoing monitoring and updates have been prioritized to ensure continued compatibility. Since no accessibility issues were identified during the repeat test run of the application on different Android-based smartphones, we have given additional attention to ongoing monitoring and updates to make sure that compatibility is maintained in the long run. Highlighting the app's offline navigability, and emphasizing its internet-independent features could be beneficial in promoting its utility to learners in diverse settings. Conclusions and recommendations. The study aimed to conceptualize and validate the interactive offline smartphone-based Android application design to ensure that the application aligns seamlessly with established curriculum standards set by the Department of Education and address the learning process in grade 9 at Tawagan Sur National High School. The researcher followed the ADDIE model, analysis, design, development, implementation, and evaluation as guiding principle, resulting in the creation of a mobile application intended to complement the teaching and learning process. The developed mobile application was deemed suitable for its intended purpose after meticulous validation by expert validators. Now, this validation encompassed both the application's contents and its overall performance. The results of this validation effort were notably positive, achieving an acceptance level that is apparent in all aspects, including integrity, learner focus, usability, and accessibility with a perfect score of 100%. The core objective of this evaluation was to ascertain whether the learning material is fit for reproduction, redevelopment, or inclusion within the catalog of quality assured learning materials under the LRMDS Learning Resources Management and Development System. Based on the validation, it is evident and shows the validity of the educational soundness of the contents of the interactive offline smartphone-based Android application. It also revealed that the interactive offline smartphone contents were disclosed as very high. Considering the range of the deviations, it is evident that they are more homogeneous. It means that the responses of the expert validators towards the contents of the IOSBAA are very similar. On the other aspects, the overall application performance of the interactive offline smartphone-based Android application was very high. It is also evident that the application's design, accessibility, usability, and efficiency garnered the highest ratings, which entails that all the evaluators agreed that the application's design is very appealing. It can be easily used without an internet connection. Users using the application system and the application is highly practical for the user's utility. Through accuracy and reliability were posted to be the lowest among all criteria. The performance was still very high. The lowest among all criteria, though accuracy and reliability were posted to be the lowest among all criteria, the performance was still very high. The overall variation in the combined data was modest, indicating that the validators had similar and consistent evaluations of the material. The content in the SBAA was considered in terms of its structure and designed to support independent learning while sparking interest and engagement. The contents within the mobile application were carefully crafted to align with the most essential learning competencies outlined for the junior high school curriculum in Science 9. From these findings, incorporating the SBAA would greatly improve both teaching and learning, making them more effective, organized, relevant, interesting, and comprehensive. Based on the study's findings and final thoughts, the subsequent recommendations and suggestions have been formulated through the analysis of data. First, incorporate various examples ranging in difficulty from easy to challenging. Conduct a pre-test, post-test, quasi-experimental study to gauge the effectiveness of the Project IUSBAA in improving students' learning of science concepts and skills. Third, encourage other junior high school teachers to utilize the developed Project ISBAA in their classes to identify potential usage issues and further validate its efficacy. Fourth, the Project ISBAA could serve as a model for creating offline smartphone-based intervention material for other topics in science subjects within the junior high school curriculum. Five, when implementing, distribute the mobile application via the APK format as Android utilizes this to distribute and install the apps. Six, to expand the application's accessibility, analysis involve a broader student and expert population in further assessment. Seventh, provide junior high school teachers with comprehensive professional training and workshops focused on learning material development principles. Eight, share the development and validation process of the Project ISBA during the school learning action cell sessions. 9. Broaden the source of teacher-made learning materials extending beyond the central office to regional contributors. 10. Encourage school administrators to actively initiate, develop, and validate learning materials across various aspects of junior high school science subjects within the educational system. Here are my references. Here is the action plan for Project ISBA in Science. Here is the financial report. Here is the informed concept form. The LRMDS Educational Soundness General Evaluation Tool. The evaluation and review for development of new non-print materials sourced from the LRMDS. And lastly, the survey questionnaire for interactive offline smartphone-based Android application teaching science, adapted from Institute of Electrical and Electronics Engineers for software test document. And that's it. That's all for my research entitled Development and Validation of Project Interactive Offline Smartphone-Based Android Application in Teaching Science. Thank you and have a nice day.